On March 14th, 2024, Starship kissed the edge of space, a leap towards our Martian dreams. It officially entered space for the first time. Yet, its dance with the cosmos was incomplete because it missed the final step of having a successful landing.
Unfortunately, did not survive. That being said, that's okay. It survived several seconds.
Starship is at the forefront of our cosmic quest to reach Mars. And SpaceX has designed this spaceship to make Mars not just a destination, but a home. Even though it is closer than ever, will SpaceX conquer the cosmos and land a Starship on Mars? Why haven't they been able to conduct a successful re-entry? In order to understand this, first start at the beginning, with the history of SpaceX and the development of this rocket. In 2002, Elon Musk founded SpaceX with a groundbreaking vision to make human life multiplanetary.
Musk truly believes that low-cost space exploration is essential to the survival of mankind.
I think it's important that humanity become a multi-planet species. I think most people would agree that a future where we are a spacefaring civilization is inspiring and exciting compared with one where we are forever confined to Earth until some eventual extinction event.
Central to this vision is Starship, a spacecraft designed not just for Earth orbit, but for carrying humans to Mars and beyond. But why Mars? Musk argues that a multiplanetary existence is crucial for the long-term survival of humanity, offering a plan B in the face of Earth-bound catastrophes. Starship stands as the linchpin in this plan, offering a fully reusable design that dramatically lowers the cost of space travel. Its development represents not just technological innovation, but a step towards a future where the stars are within our reach. As we stand on the brink of this new era of exploration, one question looms large. How will SpaceX overcome the monumental challenges that lie ahead? SpaceX's answer is Starship, which is the most powerful spacecraft ever conceived. It's designed to carry humans to Mars and beyond. But how does it work? The first major component of Starship is its fully reusable design. Unlike most rockets that are partially or not at all reusable, Starship is designed to be fully reusable. This approach aims to significantly reduce the cost of access to space. The Starship system consists of two main components: the Starship spacecraft and the Super Heavy booster. The spacecraft itself is the upper stage, intended for crew and cargo transport. It's equipped with 6 Raptor engines that use liquid methane CH4 and liquid oxygen LOX or LOX as propellants. This choice of fuel is strategic, as these resources can potentially be harvested on Mars to support future missions. The spacecraft is designed to carry up to 100 people and includes cargo compartments for missions ranging from satellite deployment to deep space exploration. The Super Heavy booster, which lifts the Starship off Earth, is the most powerful launch vehicle ever developed. It's equipped with around 33 Raptor engines. The exact number may vary depending on the mission requirements, providing the immense thrust needed to escape Earth's gravity. Like the Starship, the Super Heavy booster is designed to be reusable, landing back on Earth after launch. A unique and critical feature of Starship's design is its capability for in-orbit refueling. This process involves launching additional Starship vehicles to transfer fuel to the spacecraft bound for Mars or other distant destinations, enabling it to carry less fuel during liftoff and increase its payload capacity. One question you might be asking yourself is, just how big is Starship compared to other rockets? Like we said before, it is the largest rocket that's ever been built. The Starship spacecraft is about 165 feet tall, with a diameter of 30 feet. The Super Heavy booster adds another 230 feet, making the total height of the fully stacked Starship system around 394 feet. Now, to compare this to other rockets like the Saturn V, which was used by NASA for the Apollo moon missions, and was previously the most powerful rocket and stood at 363 feet. Starship exceeds Saturn V in both height and payload capacity. SpaceX's own Falcon Heavy stands at 229.6 feet tall, making Starship nearly twice its height when including the Super Heavy booster. Also, NASA's SLS Block 1, the initial configuration for Artemis lunar missions, is approximately 322 feet tall, making Starship significantly taller and potentially more capable in terms of payload. Now, even with this impressive technology, reaching Mars is a Herculean task that pushes the frontiers of all that we currently know. From surviving the journey to landing on the Martian surface, what technological hurdles must Starship overcome? And how close is Starship to solving these complex puzzles? Overcoming the vast distances to Mars requires innovations in propulsion, life support, and landing technologies. SpaceX's Raptor engines, which power Starship, are at the forefront of this, offering the high thrust and efficiency needed for such missions. These engines have undergone extensive testing, demonstrating their capability for deep space missions. Surviving the journey also demands advanced life support systems. SpaceX is developing systems to recycle air and water, crucial for the long-duration flights to Mars. While specific details are sparse, the company's experience with the Crew Dragon's life support systems on ISS missions provides a solid foundation for these advancements. Landing on Mars presents another significant challenge, given its thin atmosphere and unprepared surfaces. SpaceX is refining Starship's precision landing capabilities through iterative testing, aiming to master controlled descents and landings on a variety of terrains, a critical step for Mars. Lastly, the concept of in-situ resource utilization, ISRU for short, generates fuel on Mars from local resources. The technology is vital for return journeys and sustained presence on Mars. SpaceX's plans involve extracting water from the Martian soil and atmosphere to produce propellant, a complex but crucial strategy for Mars colonization. So if SpaceX believes that it can reach Mars with the technological capabilities that it has with Starship, when does SpaceX believe that it will actually achieve a Mars landing?
How much time before there's regular travel back and forth to Mars?
Well, I think it's going to take a while to build a real civilization. The threshold that really matters is, do we have enough resources on Mars such that if the spaceships from Earth stop coming,
you can survive?
Yeah.
SpaceX's timeline for reaching Mars is ambitious, with initial plans targeting the mid-2020s for the first manned mission. However, in the realm of aerospace, timelines often shift due to the complex nature of developing groundbreaking technology and the rigorous testing required to ensure safety and reliability. Despite these challenges, SpaceX has made significant strides, marking critical milestones that keep the dream within reach. Key among these milestones is the recent successful completion of multiple high-altitude flight tests of Starship prototypes. These tests are crucial for demonstrating the spacecraft's capabilities, such as vertical takeoff and landing, which are essential for Mars missions. Progress towards building the infrastructure needed for such missions, like the expansion of Boca Chica facility to accommodate Starship's production and launch, underscores the tangible steps SpaceX is making towards its Mars goal. Also, the development of life support systems, propulsion technology, and the Mars Base Alpha concept also highlights the comprehensive planning SpaceX is undertaking to ensure that, once the milestones of reaching orbit and beyond are achieved, the subsequent steps towards colonization are already in motion. With all this being said, getting to Mars has an extreme amount of risk. What are some of the risks that SpaceX is preparing for and hoping that Starship will be able to solve? One of the most significant risks involves the reliability and safety of the Starship spacecraft over the long-duration interplanetary voyage. To address this, SpaceX conducts rigorous testing and has developed autonomous onboard systems capable of diagnosing and repairing issues in real time. Also, radiation exposure during the journey presents another major risk. SpaceX is exploring advanced materials and shielding techniques to protect astronauts from the harmful effects of cosmic rays and solar radiation, a crucial factor for ensuring crew health. As we stand on the brink of interplanetary travel, how does Starship alter the future landscape of space exploration? What does a successful mission to Mars mean for humanity's place in the universe? As you can probably tell, Starship is not just a spacecraft. It's a beacon for the future of human exploration, representing a pivotal shift in our approach to the cosmos. With its unprecedented capabilities for carrying humans and cargo to Mars and beyond, Starship is poised to redefine interplanetary travel, making the dream of colonizing Mars a tangible goal within our lifetime. The successful deployment of Starship to Mars would mark a historic milestone in human history, akin to the Apollo moon landings, but on a much grander scale. It would signal the beginning of a new era where humanity is not confined to a single planet, opening up possibilities for scientific discovery, resource utilization, and even the expansion of human civilization across the solar system. The journey of Starship is not just SpaceX's story, it's humanity's leap into a future among the stars. If you like this video about SpaceX, you might like my other video about how in recent years a mysterious Chinese company is now selling more electric vehicles than Tesla, and how this might affect the future of the electric vehicle market. Until next time, keep looking up into the stars.